So welcome everybody. This is the Cloud Linux internship team. Myself, Vishal, Alap, Yanesh, and Adrian. And our project was, we call it face and object detection with using the AWS service Rekognition. We put together a couple of demos which shows how we've used AWS Rekognition in combination with a couple of other tools, which we will go through. Project overview. Our application is essentially ITEXPS Inc. as a company or as a school that registers either a new employee or a new student as they come in. The way they are registered is will be shown in the demo. We store their pictures, the reference pictures, in an S3 bucket. It is captured, the image is captured. After that, it is captured, for example, the employee or the student is coming in every day, and it's done as a security check where their picture is captured to ensure that it's the same person attending, as well as to record for attendance. This is then compared with the image that was stored from the day of their registration, and it's stored in a DynamoDB database, and it confirms whether the employee or the student coming in is actually an employee or student or not. Some real life applications, again, the application that we chose was more of a security and access control application. So this could very well transition to photo verification for authentication, restricted area access, for example, at an airport secure location. It could be for smart doorbells and for secure entry purposes. For example, if the person's image is verified, then a lock could be unlocked for them to enter the premises. This could also be used in a retail and customer service type experience environment where there could be automated checkouts, or a store could use this to capture images for demographic analysis. It could also be used for content moderation and digital media, where certain people, if they're flagged, then the content associated with that person could automatically get flagged. It could be used for photo tagging and organization, and as well as celebrity recognition. Some of the these are the AWS services that we used in Amazon S3, the buckets for storing images, AWS Lambda for automatically triggering S3, and DynamoDB for storing the metadata for attendance and registration in a table. The API gateway was used to call the AWS Lambda service. And then, of course, Amazon Rekognition was used for the image recognition part. Some of the coding languages used were HTML, CSS, JavaScript, and Python. Python was the scripting language. HTML, CSS, and JavaScript were used for the GUI that was developed, as well as we used a software called Streamlit in order to present the GUI. And now Yanesh will do a demo on the registration portion.
For ITEXPS system registration system for the new hire employee.
Okay.
For the new employee. So first, what it will do is employee would register in a web form. When the picture is captured with the employee details, it will automatically call the API. As soon as the employee click register, it will trigger web form to transfer to Lambda function, where the Lambda function would call and store the image into the S3 bucket, and all the metadata would be stored under DynamoDB. I'm going to quickly show you a demo on that. So we do have one of the portal for employee registration where I'll put a name test user and employee ID, department I'll enter. And when we open the camera, it will allow employee to take the picture of for himself. And so here, the picture would be taken, and as soon as I click register, the Lambda function, the API would communicate with Lambda, and it will store the image into the bucket, and metadata would be stored under DynamoDB. Now, this is our S3 bucket where I can do the refresh page, and we'll have the test user right here. So this is how the employee there is an employee bucket under S3 bucket. There is an employee folder where it stores all the employee details, and the data would go to DynamoDB. Let's go to the presentation one more time. All right, then there is another demo for attendance verification. Adrian would take over on that.
Thank you, Ganesh. So basically, this is the workflow for our attendance. So we have a Python script, which basically does all the work. So the first part is we have a camera. The Python script will open a camera using the CP2 library, Python library, which allows you to do that. And then after it takes that photo, AWS Rekognition is a service which handles most of the machine learning and the work. What it's able to do is it's able to detect any labels or objects in the photo and say with a certain level of confidence in the form of a percent, how confident they are that the label will be in there. It can also detect faces, and it will provide details like the estimated age range, if it's smiling or if the person's smiling or not, or any emotion for that matter, and their gender. It then uploads that information to S3 bucket as a general image, and finally it goes into DynamoDB. So we created a database for DynamoDB called attendance sheet. So for any person who is a verified team member based on the images that we stored in our S3 bucket, it will store that information in the attendance sheet database and mark them as present. If not, then it won't add anything to the attendance sheet. So now I am going to run the application. Okay, so basically, image right here. I can just take a photo right now, and then it'll perform the analysis. As you can see, it's uploading to S3, saying analysis complete, and it's being stored to a different database. So Object Spaces is a different database that we use that stores generic image detail for every image that we capture. So as you can see, there's a box around my face that shows my emotion, calm, and then the estimated age range, 18 to 22. So it also has label detection for objects and scenes. So it says head, person, face, body part, and also computers in the background and other things like electronics, laptop, PC. It also has the percent confidence for each of them. And then like it shows here on the top, it also has the face detection information again. And it also has team member attendance verification. Because I already uploaded an image, a photo to the S3 bucket, it can verify me and it says, welcome Adrian, match similarity 100%. You can also see in the database, if I just refresh right here. Yes, so it also stored the information in the attendance sheet that and marked me present. It can also test with people who are not in the S3 bucket. So I'm going to clear this photo. And yes, so we're going to test it with Alap here. Oh. All right. And it shows his image details. And as you can see down here, because he's not in the S3 bucket, it says unrecognized, this person is not team roster. And likewise, the attendance sheet should not really update. And as you can see here, the attendance sheet is not updated at all because it doesn't recognize this person. So that is basically the demo for the AI recognition. Now for the methodology, what we had were three major steps versus registering the employee. So basically, we created a website using S3 to fill out information. The user registers by filling name, ID number, and occupation. The user then uploads their photo, and the photo gets uploaded to the S3 bucket once registered, which is what Yannick showed you. Then there are the recognition basics. We first used a Python script to capture the image. Then there wasn't much configuration involved. What we had to do is just create an IAM user with the correct permissions for S3 and then DynamoDB. And then we also had to get the correct AWS CLI credentials. This allows you to basically run recognition and allows you to basically print out all this information here on terminal. And then the Python script could also be used to detect any objects or faces. And finally, we had advanced features like the graphical user interface, which I just showed you, which used Streamlit to perform all the steps above for user-friendly access. And then for any detected faces, we draw a box with face details. And finally, we compare a face in the image to any of the reference S3 photos, and if there is a match.
A bit more of a complex project that we worked on, and it had two different parts to it, the registration part and then the verification part. Some of the challenges that we faced were, one of them was Streamlit. Initially, Alap and I, we also did try to do this with T-Kinter, but then Adrian and Danish suggested Streamlit, and when we did it with Streamlit, the interface was much cleaner. We were also making sure all the command line tools were up to date. There were installation issues, and so we had to work through that. We also had some issues with the DynamoDB tables. One of the big ones was figuring out how to use the partition keys. We had in the Python script, Python being case sensitive, there were some issues with the keys not matching, and so we had to go back and forth quite a bit in order to ensure that was being. Initially, we were getting a lot of errors where it would say nothing was registered in the DynamoDB table, and then one of the last things was just being able to fix certain variables, and the simple fix was, again, capitalization. That just goes to show, how much detail there was in. In conclusion, we feel that this was registration and face recognition 1.0. We move on to 2.0. We would try to do a bit more of custom recognition, where we could display images such as, once the image is detected, we could display messages such as welcome, good morning, or how are you doing today, things like that. Also, if based on the facial recognition, if the person is not calm or smiling, we could based on the emotion, we could show a message that says, I hope everything is okay, you look sad. Those are improvements that we could do. Additionally, with the object detection part, We could use a Python library or AWS Rekognition, where we could try to scan the full body and try to detect weapons on that person. Thank you very much. We're open for questions.
Give a big round, first of all. First of all,